Welcome. Let me introduce you regression and correlation analysis using the same example which was in your homework assignment. First, the regression and correlation is used to investigate relationship between quantitative variables. Chi-square test of independence was used to investigate relationship between two qualitative variables. Regression and correlation will be used in case of quantitative variables. Now, when we are talking about correlation, in case of correlation, we doesn't distinguish between a variable which is cause and which is effect. In case of correlation, we are investigating just if two variables are behaving in similar way. So you can use, for example, curl function in Excel, which calculates correlation coefficients. Select variable 1, variable 2 observations. It doesn't matter which will be first and which will be second, because in this case it's not important. Click OK and you will get correlation coefficient value. Correlation coefficient. And this one is Pearson's correlation coefficient. Correlation coefficient can take values between -1 and 1. If it's close to 0, it means no correlation or very small relationship between variables. If it takes positive value close to 1, it means strong positive correlation. If it takes negative value close to -1, it means strong negative correlation. Positive correlation means positive behavior. So if variable 1 is increasing, also other variable is increasing too. Negative correlation means if one variable is increasing, another one is decreasing. So in this case, it's strong positive correlation between these two variables. And what is important in case of Pearson's correlation measures only linear relationship. Actually, it measures how close is this relationship to linear function. Second part of this analysis, it's called regression. So if there is strong relationship between two variables, maybe you would be interested also in function which could be used to estimate this relationship. If you could estimate function, then in such case, for example, if you would know number of earrings, you estimate function, then you can estimate a value for sales. So regression part means estimating functional relationship, estimating a function which will describe a relationship between these two variables. Important thing, in case of regression analysis, first step it's necessary to select which variable will be dependent, so which variable will be effect and which variable will be a cause. Now we have only two variables, so we are talking about simple regression, and we will start with the most simple function, which is linear function. So effect will be sales, because we expect that sales depends on number of earrings. Effect will be sales, we call it dependent variable, dependent or explained variable, because we are going to explain this variable, the behavior of this variable, using explanatory variable, so number of earrings will be explanatory, or independent variable. Before we'll proceed with regression analysis, we will look at functional form, or we'll look at relationship between these two variables. I will insert scatter plot, blank new scatter plot. Then I will use right click and select data. First, I will select values for independent variable, number of earrings. Second, I will select Saturday, Sunday sales. Once again, sales. And now you can see, in case of 2 earrings, this was the level of sales. In case of 4 earrings, this was the level of sales, and so on. So we have just few observations, but it's clear that it would be possible to describe this relationship by using some mathematical function. So we can try to fit in some function. If you will use right click in this chart and select add trend line, select add trend line and select what kind of trend line you would like to add. The most easy is linear one, and if you would like to see also equation and R square, display equation on chart, display R squared value on chart. And here it is. That's the equation and that's the linear function. So actually this function was estimated using regression and correlation analysis. This is just fast and easy way how to investigate the relationship. So in this case it's obvious that it would be possible to use a linear function to estimate this relationship. So we are going to try fit linear function into these real observations. How to estimate regression in Excel? So once again, we are going to estimate linear function. It works the way you should know the functional form you are going to estimate. In case of linear function, you have one dependent variable on the left side, one independent variable on the right side in function. It works the way we are going to select data analysis, and we are going to estimate regression. You should select variables which are in function. First, range of dependent variable, which is sales. Then X range of independent variable or variables. In this case, we have only one variable on the right side, only X values. We will select only X values. If there would be more independent variables, then all independent variables or more variables, all variables should be selected into X range. If you selected also labels, you should check on labels. We will select output range, and then Excel offers you some additional outputs like residuals or residual plots. It may be useful for you sometimes. Click OK and you will get regression output. Actually, this linear line, this linear function estimated in this chart is described in this regression output. And you should be able to explain all these values. First multiple and R square, then significance F from ANOVA table, coefficients, and p-value. So we will start from the beginning with multiple R. This first value, multiple R, equal to 0.93 almost. It seems familiar if you remember Pearson's correlation, 0.92. So this first value is correlation coefficient. Coefficient of correlation measures strength of relationship between, in this case, between these two variables. It's close to 1. In this case, it means very strong relationship between sales and number of airings. If it would be close to 0, it means weak relationship. In regression statistics, is multiple R value always positive because it's calculated like square root of R square. So in this case, it would be always positive, and relationship between variables will be denoted by sign of correlation coefficients. Second value, R square. R square, sometimes it's called coefficient of determination. Coefficient of determination. Coefficient of determination measures goodness of fit. Goodness of fit. In other words, how close is this function to real observations? In this case, how close? This is our estimated function, this linear line, and these are real observations. So how close this function is to real observations. If it's close, the goodness of fit or R-square value is high. If it's closer, it's higher. If it's not very close, then R-square value would be smaller. And we also say that R-square value is the proportion of explained variability of dependent variable. In this case, actually, we would like to explain behavior of annual sales, and this linear function explains 86% of variability of annual sales. That coefficient of determination is denoted R square because, in fact, if we square value of coefficient of correlation, we will get R square value. So these two values are very important. Be careful. Multiplier strength of relationship R square, goodness of fit. Adjusted R square is used when you would like to compare different estimated functions. Actually, higher R square means better function, better goodness of fit. So if you would like to fit the function which is the best to describe the relationship between two variables, you should select the function with the highest R square value. But in fact, if you would add additional explanatory variable, the R square value will increase. So if you would like to compare functions with different number of explanatory variable, you should use adjusted R square to select the best one. Standard error, it's kind of error committed in model observations. We used 5 observations to estimate regression function, and one important thing, we estimated this linear function using 5 observations, and this function was estimated using ordinary least square method. So when you will prepare for your exam, focus on what is ordinary least square method in study materials. Every time when you click regression in Excel, you will use ordinary least square method to estimate regression coefficients. Analysis of variance table. Once again, it's similar to analysis of variance we used before, but in this case, once again, it's variability. But here is different variability from what was in previous analysis of variance table. In this case, the sum of square is total variability. Total variability means variability of sales. 150 sum of squares of variability of sales. Actually, residual variability is the difference between value of sales and predicted value of sales. True value of sales or real value of sales are those dots in chart, and predicted values of sales are the values of sales on this line. So if you clicked also residuals on, then you can see what are the predicted value for sales and the difference between real and predicted value is the residual, so which is also in regression output, residuals, difference between real and predicted values, between real values and values on line. And if you square those residuals and sum it up, then you will get sum of squares or residual sum of squares, and we call it unexplained variability. So that's the proportion of variability which was not explained by regression model. And one more thing, if you would calculate average value for sales and average value for real values and for predicted values, these average values will be equal. So the same way as you calculated as you calculated total variability, which means real value minus average value and calculate sum of squares. If you would do the same with predicted value, and you would do the same predicted value minus average value, and calculate square, and you sum it up, then you will get explained variability. So if you would use predicted values instead of real values to calculate variability, you will get regression or explained variability. So when we mentioned that R square is proportion which is explained, proportion of variability of dependent variable which is explained in this regression, it means explained variability divided by total variability will give you proportion which is explained, or will give you R square value. This analysis of variance table is used to find out if this model is useful and if it explains significant proportion of variability. In other words, we are going to test hypothesis that R squared value is equal to 0, so actually we explain nothing, or R squared value is different from 0. So we explain, it doesn't matter what's the R squared value, we explained some significant proportion of variability. So this we can find answer in this table. So this is sum of squares, then mean square column. So actually sum of square is divided by degrees of freedom to calculate mean square for explained variability and mean square for unexplained variability. Regression is the number of explanatory variable. Residual is actually number of observations minus number of estimated parameters. And if you calculate mean square, you get mean square for regression variability or explained variability and mean square for unexplained variability. In this case, test statistics is just explained variability divided by unexplained variability. So you can see explained variability is 19 times higher than unexplained variability in this model. So if you would like to decide which hypothesis should be accepted and which one should be rejected, then you should compare this F with F critical. And in this case we have p-value denoted significance F. And you should know that if p-value is smaller than level of significance, usually 0.05, it means that you should accept alternative hypothesis, which means R squared value is different from 0, or we can say that we explain significant proportion of variability. So other estimated regression function is significant, and therefore can be used to describe relationship between these two variables. Another thing, what kind of function did we estimate it? So we estimated linear function. We know this is linear relationship we would like to estimate, so that's linear function in mathematical form. We selected dependent variable observations, independent variable observations, and Excel used ordinal least square method to calculate b sub 0 and b sub 1. And we call these two values regression coefficients. These coefficients can be found in this table. So now we can fill these regression coefficients into estimated function, It means 2.6 and 3.6 actual that we estimated function. Dependent variable is equal to 2.6 plus 3.6x plus random error. That's our estimated linear function. What's the possible meaning of these two values? The meaning of regression coefficient every time depends on mathematical form. So in this case, in a linear function, it's quite easy. If the x value would be equal to 0, if x would be equal to 0, then dependent variable would be equal to 2.6. So if number of airings would be equal to 0, sales would be equal, or average value of sales would be 2.6. Regression coefficient 3.6 means if number of airings will increase, it will increase also sales. If number of airings will increase by 1, amount of sales will increase by 3.6, or that will be average increase in sales based on our data. So that's the explanation of regression coefficients in case of linear function. As you can see, in this case, according to linear function with increasing airings will increase number of sales and so on. Another thing, this regression was estimated using sample data, which means this is kind of sample results. Once again, it's necessary to use statistical inference to investigate if this result is significant, similar to analysis of variance table when we investigated significance of this linear function or significance of the proportional, which is explained. It's necessary to investigate if these two regression coefficients or these two coefficients are significantly different from 0. So once again, we are going to test two hypotheses, similar to previous one, where we test if true population coefficient is different from 0 or not. So 0 hypothesis would state true population coefficient is equal to 0. Alternative hypothesis will state true population coefficient is not equal to 0, which means if it's not equal to 0, it means that independent variable will significantly influence dependent variable. Significance of regression coefficient can be calculated like value of coefficient divided by standard error, and you would get the statistics. It's not necessary to find critical values to these test statistics because we have p-values, and once again we can use p-value. If p-value is higher than 0.05, we should accept null hypothesis. If p-value is smaller than 0.05, we should accept alternative hypothesis. So in this case we can see only regression coefficient for number of airings is significant, intercept is not significantly different from 0. Intercept can be left in function also in case if it's not significant. If number of airings would not be significant, it's only variable in this model, then it would be problem and probably the whole function would not be significant. The last thing in this regression output, as we mentioned, once again, this output is based on sample data. So these two estimated values are point estimates, and here can be found interval estimate. So regression coefficient for number of airings can be between 0.97 and 6.22. So you could evaluate significance of this variable also by this interval estimate. It means with 95% probability, number of airings coefficient will be between 0.97 and 6.22. So if we found that we accepted alternative hypothesis and number of airings is significant according to p-value, the same result can be found also by comparing interval estimate with 0. If there is 0 included in this interval estimate, variable would not be significant if there is no zero value. In such case, this variable is significant. So this was explanation of regression output in simple linear regression, and later we will try also to estimate nonlinear functions, and we will compare different nonlinear functions, and we will learn how to select the best one.